Now we will be using this to derive one formula. If it's given in the curve y is equal to x to the power of n, then it's curve. If f of x is equal to x to the power of n, then it shows you your function. Let's look at finding the gradient. Finding the gradient or derivative of f of x to the power of n by first principle. Let's proceed. This is my question. This is my solution and proof. So f dash x is lim h tends to 0 f of x plus h upon h. This implies lim h tends to 0. So this is the definition, right? Let's just label it as 1. So what happens usually, students, they struggle with its proof. So I'll be giving you the way how we can proceed it. So you can list this formula, and let's say this is your first part. Now second part, uh, let's find your f of x plus h. So it's x plus h to the power of n. Okay, and make sure that your n and h looks different. Now let's just expand it. So this is nc0 x to the power of n h to the power of 0, nc1 x to the power of 1 h x to the power of n minus 1 h to the power of 1, nc2 x to the power of n minus 2 h to the power of 2, so on till ncn x to the power of 0 h to the power of n. Now let's, in the separate space, let's find the value of these nc0, nc1 and ncn. So nc0 is your n factorial, 0 factorial, n factorial, that is your 1. nc1 is your n factorial, 1 factorial, n minus 1 factorial, that's n minus 1, n minus 1, and that's your just n. nc2 will be your n factorial, 2 factorial, n minus 2 factorial, that's your n minus 1, and you have 2 factorial, that is precisely equal to n minus 1 and your 2. Okay. Now ncn is n factorial, and 0 factorial, and that's just your 1. Let's just sub in these values over here. So nc0 is your 1 x to the power of n 0 plus n x to the power of n minus 1 h plus n minus 2 over 2 x to the power of n minus 2 h square plus 1 x to the power of 0 h to the power of n. That gives you x to the power of n x to the power of n minus 1 h plus n minus 1 over 2 x to the power of n minus 2 h square, so on, h to the power of n. So we got the expansion part, we have our formula, right? First, let's just handle this. Let's get this bit. What is it? So f of x plus h minus f of x upon h. So this is x to the power of n n x to the power of n minus 1 n minus 1 over 2 x to the power of n minus 2 h square, so on, x to the power of n upon, what is f of x? X to the power of n, and then we are dividing it by h. X to the power of n, x to the power of n is cancelled, right? Now, what this numerator becomes? N x to the power of n minus 1 h n x to the power of n minus 1 over 2 x to the power of n minus 2 h square, so on, x to h to the power of n upon h. From the numerator, I'll pull out h. So it will be n x to the power of n minus 1, right, plus n minus 1 over 2 x to the power of n minus 2 h, so on, plus h to the power of n minus 1. And then you have h in the denominator. So this h and this h is gone. Now what you have? N x to the power of n minus 1 n minus 1 over 2 x to the power of n minus 2 h, so on, plus h n minus 1. Now you have third is sorted, right? We have got the inner part. Now what is left? We need to take the limit. So let's take the limit. That's the fourth step. So f dash will be the limit of h tends to 0 n x to the power of n minus 1 n minus 1 over 2 x to the power of n minus 2 h, so on, plus h to the power of n minus 1. So in the place of h, let's plug in 0. So wherever h is there, just sub in 0. So you have n x to the power of n minus 1, right? n minus 1, because lim h tends to 0 means your h is approximately equal to 0. So that is n x to the power of n minus 1, where your f of x is x to the power of n.